In this video, I'm going to give a hardware overview of the DroneBlocks Compute Kit hat. This works with a Raspberry Pi, and then we'll get into installing a DEXI-OS and doing a flight with my drone and showcasing some of the capabilities. Our goal with this hat was just to simplify development, make hardware more accessible for your drone applications, and then use DEXI-OS or any implementation that you'd like to unlock the hardware capabilities through software. So let me just dive in quickly. So we have our UARTs, UART 0 and 1, and for any Pixhawk flight controller, you have TLM1, which will plug into UART 0, and then we have a TLM2, which will plug into UART 1. Now those aren't set in stone, that's just how we've configured them. And what that means is with TLM1 plugged into UART 0, we run Mavlink router and we get Q-round control communications or anything that supports Mavlink. That is all done through a wireless interface. We broadcast a Wi-Fi network with the Pi 5, and so you'll get Mavlink router sending packets to your ground station. Then for UART 1, we have a ROS2 in the micro DDS bridge, and so what that allows us to do is access PX4. For example, you'll notice that when you toggle your flight mode switch, your LED will change different colors, and that all happens through ROS2 nodes that are communicating with the PX4 topics. And speaking of LED, we have the LED ring that ships with the kit, 3-pin connector that just plugs into the LED port. So you have access to LED control at the entire ring level or the individual pixel level. You'll see here we have our M.2 connector. And so for future applications, if you want to use an AI accelerator, this is the Halo. You can just put that in and then leverage the capabilities there. Then on the rear side, we have a couple of ICs. One is the PCA 9685, and that just makes it dead simple to plug in a servo directly, get power and all of that from your hat. And then I'll just demonstrate here. Plugging in, I'll just use port 0, ground to the outside of the board. And the other IC here is the TCA 9555. For example, if you wanted to connect to any of the GPIO ports, then here we have the ability to trigger a 5-volt output. So we really wanted to focus on some of the things that we find that are important when we're doing any sort of drone application development. That being said, let me go ahead and walk through the steps of flashing DEXI-OS and showcasing its capabilities.
I'm at the DEXI-OS repo in my browser, and I highly encourage you to bookmark this because this is where we publish our releases. So in this video, I'm going to demonstrate a DEXI-OS version 0.10 and make sure that you take a look at the release notes and understand that there is an image for the DEXI 5 with a maximum compatibility version of PX4 1.15.4, and the one we're interested in is the DEXI Compute Kit image. This is what we'll be flashing today and testing on a larger drone. It's an AVR drone with 10-inch propellers, but obviously this is fairly hardware agnostic. And so PX4 version 1.16.0 is what we've tested with. So I'm going to go ahead and click this. We'll go to the download button. I've removed my micro SD card from the Raspberry Pi 5 and I placed it into my Mac, and I'm going to now proceed with flashing. Now, previously I've done a video showing Balena Etcher. So if you have that downloaded, you can use Balena, but in this case, I'm going to use a Raspberry Pi imager, which works just as well. It's really your decision what you want to use. So let me go ahead and fire that up. I'll click choose device. We'll use the Raspberry Pi 5, and then we'll scroll down to use a custom image. On my desktop, you see here I've downloaded the version 0.10 for the compute kit. So that is selected, and then I'll select my micro SD card. I do not want to apply OS customization settings. This is already pre-baked into the image. It'll have our network information, our passwords, all of that stored, and then when it boots, it will broadcast the DEXI network. So all existing data is going to be erased. That's okay. It'll prompt us. DEXI-OS is now done being flashed. I wanted to share this tip. If you're like me, I can sometimes be a little impatient. There is a verification process going on for both Raspberry Pi Imager and Balena Etcher. You can cancel this. I've had success in doing this. I do so many flashes and tests that this slows me down, so I'm going to go ahead and click cancel, verify. Then our micro SD card will be ejected, and we'll go ahead and put this in our compute kit and boot.
Our goal with the compute kit is to be drone or hardware agnostic. So what I'm sharing here will apply to any drone that you are able to mount the compute kit to. Now, before I proceed, the one thing that I feel is often overlooked is the compute kit or any sort of companion computer is not necessary for your drone to fly. So you should be able to get into stabilize mode, altitude mode, position mode. In this case, our drone has an arc flow sensor mounted to it that gives us great position hold. And what the compute kit allows us to do is get into more programmatic control to be able to use ROS2, to be able to control the LED, the actuators, and also use the ROS2 nodes for programming, whether that's with Python or Node-RED. So I want to make sure that that is clear, that this is not necessary to fly. Okay, with that being said, I'm going to go ahead and power up my transmitter. I'll go ahead and power up my drone via battery. Anytime you flash DEXI-OS, you should expect maybe around a 2-minute first boot, sometimes a little bit longer. But that being said, we'll just do a quick check. I'll go ahead and turn my drone up. I'm going to toggle the flight mode switch. Right now we're in stabilize, which the default is white. Altitude, which is yellow. And then position, which is green.
We've done a quick visual LED test. My drone is still powered up and it is broadcasting a network, DEXI B501. Obviously, these last 4 alphanumeric characters will be different for yours. And I'm going to connect with Q ground control, but before I do, I think it's important to understand what's going on under the hood. So we have our Mavlink configuration here for serial telemetry 1 baud rate. Now, if you recall, we have telemetry 1 on Pixhawk connected to UART 0 on the compute kit. So DEXI-OS will recognize that and then allow us to communicate with our ground station. That's with Q ground control. And then we have our micro DDS configuration. That is the telemetry 2 port. And if you recall, that's connected to UART 1 on the compute kit. So that's what allows us to do Q ground control and ROS2 communication. Let me go ahead and launch Q ground control. I'm going to go to application settings. You'll probably see I have a lot of different setups here, but one of the things that we want to pay attention to is 192.168.4.1. That's the IP that DEXI-OS is broadcasting from the compute kit. So I'll go ahead and click connect. And you can see here we're in our stabilized flight mode. Actually, you can tell I need to charge my battery. My transmitter here, I'll just toggle the flight mode switch. So not only does the LED change color, but if we're connected with Q ground control, it'll tell us our current flight mode. So the next step is, this is for the ROS2 stuff. I'll go over to 192.168.4.1 in my browser. We have a lot of tools running here. We'll do a ROS debug. You can see here there's a lot of topics and services running, and we're going to demonstrate April tag detections. So I'll go back to the dashboard, and just as a quick example, I'll go to our Node-RED dashboard. There will be a bunch of default flows. We'll go to April tag demo, and I'm going to right-click, select Enable Flow, and then deploy. So you'll see here that we're connected. You'll see I'm just printing in the console. There's nothing coming through right now on the April tag detections, but if something does come through, if it's a 1 or a 2 or a 3, then we have the LED turning red, blue, or yellow. It's probably a good idea to change that yellow since that could conflict with the altitude flight mode LED color, but for now I'll leave that alone. We're actually only going to test with April tag IDs 1 and 2.
Okay, I'm going to need to make this test quick. I'm running out of battery. What I'll do is I'll take off in position mode. My camera is on the left side of my drone, and so that's what's going to be feeding camera frames into our ROS node that's doing the April tag detection. So on the left side I have tag ID number 1, and then on the right side I have tag ID number 2. So if I go into position mode, you'll see we're green. I'm going to take off, and then we'll do the scan.
We've completed our April tag test. Now I'm going to disable the flow and deploy just so that's not running in the background. Sometimes I'm a bit OCD about compute resources, so I don't want to have too much running if not necessary. We'll go back to the dashboard, and then just like we have with the DEXI-5, what we're working towards is a consistent image across platforms. So as we roll out new features, we'll make those features accessible for the DEXI-5. Any drone running the compute kit, we have everything here that we do have with the DEXI-5. Obviously, in this scenario with the hat, we have servos, so that is one difference. For the compute kit, you'll be able to get servo control, and that would be possible on the 5-inch, but definitely a more challenging implementation to get access to the GPIO as well as mounting the servos. That being said, I'm going to go ahead and leave it here. We hope that you enjoy DEXI-OS version 0.10. We're actually about to roll out 0.11 in a few days with some new capabilities, so stay tuned for that. Feel free to jump into Discord if you want to join in on the conversation. And if you have any questions or comments, please feel free to leave them below. And until next time, thanks for watching.